Hello guys, welcome back. This is the video number 8 of this Pioneer SA9100 full restoration journey. On this video I will show you how to make first start without any problems. You'll use for that Variac, you have to use a dim bulb tester and you have to measure some voltages, but if you want to see you have to stay tuned and watch the video. I will show you exactly what to measure, how to adjust the DC offset, how to adjust the idling current, how to see all the process which they are happening when you start to increase the voltage of the mains. You will see also the power output performance, how much he can deliver this amplifier when it's under the load. So if you want to see all of them, you have to stay tuned. And on the end of the video, after all these performances, they are under the specs. You will see all the parts which we took together out. I will show you one more time the electrical diagrams and you will have a full picture of all the parts and you will be amazed how many they are. A lot. So if you want to have this sound, you have to go with the process step by step and you'll have this machine like this one. So let's follow together the continuing of this video and we'll see you on the next one. In this video we'll cover the first firing of this one. We'll use a dim bulb tester and the Variac to start. In the same time we will monitor all the time the idling current because this is the most important for us. And in case if we'll have some troubles inside of I don't know, power transformer, main filter capacitors, diodes or short circuit somewhere, we'll see this in the dim bulb tester. For dim bulb tester I will use a 70 watts bulb in series with the phase with the live cable from the mains, and we will start slowly to increase the voltage from Variac. So this is the main plan. After that we'll start with adjusting the idling current and the DC offset, and we're continuing with performance of this amplifier. For this performance we will use two dummy loads, 8 ohms, and a signal generator, plus an oscilloscope and voltmeters set on AC voltage. So let's start with firing this, but for this we have to hook the probes of voltmeters on the emitter resistors from power amplifiers circuits. Why? Because there is the point where we can check the idling current. So let's focus a little bit on the diagrams and we'll discuss there. So what is written here? Alignment procedure, chapter number 9. The SA9100 has to separate power amplifier boards. Yes, this we know. As viewed from the front, the left circuit board is the left channel power amplifier, the right circuit board is the right channel power amplifier. Adjustment procedures are identical for both channels, so the explanation below are given for one channel only. All adjustments are required to be made on both channels, however. Okay, so it's clear, yeah? Left and right. Okay, idling current adjustment. Remove output load, yeah? So that means you have to disconnect your speakers if you have, without applying input. Terminate input terminals number 3 with 4.7 kilo ohms resistance. I will not use this resistor. Set VR1, because when your amplifier is running normally without any input, is running without this resistor, yeah? So we'll be sure we'll disconnect all the inputs and we'll set the function knob to auxiliary 1 or auxiliary 2, yeah? Okay, so set VR1 at approximately center position, turn VR3 all the way counterclockwise, then turn on power. So VR1 is this one, VR3 is this one. So VR1 and VR3, yeah? Allow approximately 20 minutes warm up time when adjust VR3 to obtain a voltage reading of 25 millivolts between terminals 9 and 13. Okay, so the idling current is 25 millivolts between terminals 9 and 13. So now let's take the wiring diagram and to see what means terminals 13 and terminals 9. So we have here the power output transistors, yeah? Q10 and Q11, terminals 9, terminals 13. So you see, if you are going like that, you will close the circuit to R29 and R30. So these two are the emitter resistors, belongs to the power transistors, yes? So this, they will create, when the current is passing here, they will create a voltage drop, and that voltage drop you can read on pin 9 and pin 13, yeah? So we'll connect the multimeters according with this diagram. So when you will adjust VR2, what you will do, you will create, let's say like that, you will create an opening or closing of these two transistors, yeah? Because you are playing with this biasing of these two transistors, and after that on these two transistors. So this idling current should be adjusted according with the manual, because here you will adjust the current, here you will see a voltage. If you want to see current, if you have on your manual the current, you have to disconnect the power supply here, or you have to disconnect a resistor between the resistor and the transistor, and after that you will see half of the current, yeah? So you have to be aware of this, yeah? Okay, so now let's connect our multimeters. So it will be between 9 and 13. So on 9 we'll have plus, on 13 we'll have minus, yeah? And we'll make this adjustment. These pins, if you are looking, these pins are on the other side, 9 and 13, they are on the other side of the board. So here on amplifier, which is in front of us, we have the terminals of the transistors here on top. But pins 9 and 13, they are below. So I want to connect the multimeters here. So you can do this. How you can do this, I will show you here. So you will have here 9. If you are looking on this 9 point terminal, is connected with 18 terminal, yeah? And when terminal 13 is connected with terminal 15. So you can do this on the top of the boards, exactly like they are now, on terminal 15 and terminal 18, yeah? So you see are the emitters, correct? Correct. So 18 and 15. On 15 we'll put minus, on 18 we'll put plus of multimeters. Okay, so we have 15 here, so we'll put the minus here, and for the plus we have 18. So 18, it's exactly here, yeah? So you see are these blue terminals. So these are the emitters from transistors, from power transistors. So from these two pins, they are going exactly on these two emitter resistors. So we'll do same on the other channel. This is the left channel. We'll do also for the right channel same. So we'll use the black probe for pin number 15, which is here, like that. And for pin 18, we'll use the red probe. After that, because it will be a DC voltage, we have to set the multimeters on millivolts, and we'll start. And check also the probes, they are correct, fix here. Also for the other one, also millivolts, and we will start. Now let's see, according with the diagram, which one is idle. So idle, it's VR2, yeah? So it looks like it's closer to the compensation diode, yeah? So let's see where it is. VR2, it's exactly on the middle, you see? Is this one. So we have to be aware of this, of VR2, idle. So VR2, if we are going here, is this one on the middle, yeah? So we have to adjust the middle, yeah? Okay, so now let's change the position of these two multimeters. We'll keep like that, yeah? It's visible. Now we'll check the Variac, and we'll connect the amplifier on the power supply, on the mains. So on the Variac, you see the set it's on 0. The dim bulb tester, I told you, it's one bulb in series with the mains. So one bulb it's engaged, one bulb it's disengaged. So that means only one bulb it's in series now. So only 70 watts it's in series now. And now I will start the Variac. The Variac it's on 0 and I can connect the cable, the power cable of our power amplifier. Now on the power amplifier I will press on to be on, and now I can play with Variac, and I'm watching the bulb and also the voltmeters. So now I will start to increase. In case if I will have a short circuit, you see both voltmeters, they are showing me some voltage. Yeah? So now I'm increasing the Variac, you see. Here on my area I'm using 230 volts on the mains. Yeah. So you see the bulb it's dark. Yeah. So that means the current which is drawn by amplifier is not big at all. Yeah. So we see 100 volts, and I have already less than 1 millivolt. I have here. It's 0.2 millivolts. You see, and if I'm looking here also, protection and the power lamps are giving me light because the protection relay it's disengaged. So I'm still increasing. I have already 150 volts, and you see the voltage is still increasing. So I'm 100% sure I will not damage the transistors. Yeah. With this current. Okay, I have already 200 volts. So I heard the relay was engaged. So that means if the relay engaged, that means I don't have a DC offset on outputs, and in the same time I don't have any troubles on the power amplifier ports. Yeah. So I have 200 volts, I'm going to 230, 220, 230. And you see, if you are looking to the bulb, it's a little bit dim, you see? This is the reason why is the name dim bulb tester. Yeah? Because if you are looking on the current, which is passing the transistors, is not so big. You see the bias current, it's I mean the voltage for the bias current, it's very strange. Yeah, I know it's 1.4 and 1.2, and according to the manual they said to be 25 millivolts. Okay, so at least we have signal. So what I suggest to you now, to put your amplifier, the volume to be on minimum. After that, set auxiliary 1, because for sure you will not have any input here. And after that, mode to normal, duplicate off, source okay, balance to be on 0, volume on minimum, attenuator on 0, all the tone controls to be on 0, speakers output on off, because we don't have nothing connected now, muting on normal, subsonic, tone defeat on, high filter on, loudness on off, yeah, and balance on center. So this is the point where you can make the adjustments. How you will make the adjustments? Because now we are sure our amplifier it's okay. So all the jobs which we did inside are okay, and you see it was a lot of jobs. Okay, so now what you will do to adjust these trim pots, you will use a screwdriver. But if the tip of your screwdriver it's exposed, you have highly chances to make a short circuit somewhere. Yeah. So my suggestion is to use a piece of insulation tape to cover the tip, and you let only a small part of the tip to avoid any accidents. I will show you in a moment. So just cut a piece of insulation tape and just cover your tip like that, you see. And now if your screwdriver it will touch something, it will not affect nothing. You saw how the dim bulb tester it looks. Now what I will do, let's start to increase the current, the voltage on the right multimeter. Let's increase to 10 millivolts. You see it's increasing. So we have 10, yeah? Now the transistors, they will start to warm up and the voltage should play here because of the compensation diode. This compensation diode, she will take care about the temperature of this heatsink. I will do same for the second one. Also increasing to 10. I suggest you to not put the setting for the bias according with the manual. I suggest you to let lower because it's better for your transistors. You will live. Usually I'm leaving about 60-70% from the value which is stated on the manual, because if you have problems you will see on oscilloscope later on if you have this crossover distortions. Yeah, so we'll check one more time the dim bulb tester, and if you're considering everything it's okay, we can bypass the dim bulb tester. So dim bulb tester, you see it's a little bit more brighter. Yeah, okay, so this is how it looks. And now what I will do, I will reduce the voltage on Variac. I will take out our connection cord, I will fix here, and now I will start the Variac and I will bring 230 volts according with the specification. And again, in the same time, I'm checking the voltmeters. You heard the relay, so we'll put on 230 volts. Okay, and you will see, because we bypassed the dim bulb tester, our voltages are a little bit higher. So from my point of view, are okay. Now I will suggest you to take a temperature laser gun if you have and monitor the temperature on the heat sinks. 17 degrees, 17 degrees. So according to the manual, they say to leave 20 minutes for warming up. So let's count 20 minutes from now. We leave like that, and after they will be warm, we'll adjust the trim pots more. So I will try to not adjust more than 15 millivolts. Yeah. So my set point, it will be 15 millivolts, and you'll see the temperatures, they are playing up and down, and it's normal because the heat sinks, they will start to be warmer and warmer. Yeah, okay, so now we can focus, we leave like that, and we can focus on DC offset to see the value of the DC offset. What is going the DC offset? The DC offset is the measure, is the balance between transistors. So what means DC offset? Usually DC offset, it starts here on the differential pair section. Yeah, so here on the differential pair, if you are looking, we have also here VR1. VR1 is this trim pot which is taking care about the compensation of opening and closing of transistors. So the bias, it's opening both transistors and is closing both transistors in the same times, yeah, because it's current on both base of these two transistors. But here on a differential pair, this differential pair, he is giving you signal to one or the other transistors, yeah, according with the voltages. So this DC offset, it's giving me the opportunity to open both transistors same, yeah, to have here 0 millivolts on the output, on the midpoint of these two emitter resistors. So now we have to find the pin number 12, the terminal number 12 output, and here we have to put our multimeters and to adjust the DC offset, or we can put here on 23. Yeah, you see, 23 pin. So we have to look for this 23 pin or 12. Let's see where is 23 or 12. So 12, it's here down, you see, and 23, and pin 23 is here. So we can connect the plus probe of our multimeters on pins 23, and the black one will connect to the chassis of our amplifier to see exactly the measure. So let's start to do this. So we'll do for the left channel. So we'll disconnect both terminals, both probes, sorry. So we'll fix plus probe on the terminal 23. Yeah, you see, is this one closer to the bias trimmer. Yeah, and with minus probe we'll connect on the chassis. Yeah, and now we will have, you see, 7 millivolts DC offset. So the idea is to have closer to 0. So we'll do same for the right channel. We'll disconnect plus probe, we'll disconnect minus probe. Here is pin 23. We'll connect plus probe on the pin 23, and the minus probe will connect to the chassis, and we'll have similar, yeah, you see, 6.8, 6.7. So now we'll adjust according with the manual. So let's see what is written, what is stated on the manual. In the manual they said like that: adjustment of neutral potential. Remove output load terminal, terminate input terminals of circuit board with 4.7 kilo ohms resistance, then turn on power. Allow approximately 20 minutes warm-up time, then adjust VR1 to obtain a voltage reading of 0 volts plus minus 10 millivolts between terminal number 23 and ground. Yeah? So, what they said, to have 0 volts plus minus 10 millivolts. And we have 0 volts, and we are inside that range. Yes, plus minus 10 millivolts. We have plus 7 millivolts. This is the reason why I'm using this multi-turn trim pots, because they are helping me to adjust very fine the value. So about the diagram, I explained to you what is going on with VR1, what he is doing. He is playing with the differential pair with Q1 and Q1 and Q2 or 3. Q1 and Q2, yeah? So it's adjusting the biasing of these two, yeah? So we have to be aware of this. Now, let's adjust this VR1. So let's start with the right channel. So the right channel. So you put the tip of your screwdriver and you will adjust. You see, now it's increasing, so I have to move on the other side. You see, it's dropping. So it should be on 0. This DC offset is influencing the idling current, but the idling current is not influencing the DC offset. So after we will adjust this, we have to come back to the idling current and to adjust again. So the idea is to adjust the trim pot to have here on the reading between minus 0 and plus. You see, now it's only positive. So it's sitting more than 0. So because it's fluctuating and it's something normal, I want to have the reading exactly on 0 or between minus and plus. You see, now it's 0.34. and still going. You see minus, plus, minus, plus, minus, plus. So now it's almost there. To be sure where it is, I'm pressing this and I see the min max. You see, my minimum is minus 0.09, average, and the maximum 0.3. So that means I can play a little bit more down. It's still more positive than negative, yeah? This is what I'm doing here on this way is much more than normal. Let's say, yeah, this is really fine tuning. So you see now it's going opposite. It's minus 1 and 0, 1. But now also it's fluctuating if I'm moving the air here, you see? Everything is depends. If you have air flow around you, it will fluctuate and it will change the value. So let's come also on the other channel. We'll do same. So this one you see is still 7 millivolts, yeah? So we'll play same. I can feel that the heat sinks started to be warm. You see what I'm doing here? I'm just turning the screwdriver, yeah? And you can see the reading is going to 0, closer to 0. The idea is to go on minus. So now you see it's 1.1, 1.0. A little bit lower, 0.8, 0.6, 0.5, 0.6 again, 0.4, 0.2, 0.1, 0.2, 0.0, you see? So it's starting to go on minus. And now it's only on minus, so that means was too much. And now it's also on the plus. So this is the way how I'm doing the DC offset and the idling current. You see, it's very, very, very simple, yeah? This is the reason why I like to replace these components, because it's giving me a better performance. You see, they said on the manual to have 0 volts, so 0 volts, not 0 millivolts, yeah? Because if I'm changing the range now, you will see it here it's 0 volts and I have 0.0001 volts, yeah? They said to be plus minus 10 millivolts, yeah? But you see what is the value here? It's almost 0, yeah? So it's perfect, you see? So this amplifier, it's running very, very nice. And this is how it should be. Yeah. Now let's change the probes back and we will read one more time the bias. And also we can have the temperature now. You see, I told you starting to increase the temperature, 18 volts. So both of them they're tracking same. Yeah, they are tracking same. So let's change the probes. Okay, so let's change the probes to see the idling current again. So you remember, plus on 18, minus on 15. And we have 13.7, you see? So was changing a little bit. So let's do also for the left channel, plus on 18, minus on 15. Okay, so 13.7, 13.0. So I said we will not go more than 15 millivolts, yeah? So let's increase a little bit more. So I'm still increasing, yeah? Okay, so we are on the 15, yeah? Let's do for the left channel also. 13. 13.3, 13.5, 14, 15, so on, yeah. 15, yeah. So you see, 15.0, 14.9, so a little bit more here. Okay, so you see, 15, 15. And now if you'll go for volts, you can see 0.15, yeah, which is really nice. 15.0, 15.0. So it's exactly like it should be. But now, I told you, if I'm changing the temperature here, you see, also the value is changing because it's normal. Because the compensation diode, it's filling the heatsink, it's colder, and she will compensate back. You see, I just stop and she is increasing the voltage. If I'm putting more air, it's dropping again. So this is a way how you can check if it's going okay, your compensation diode. If you'll put the finger on it, also it will increase because you'll give more temperature, yeah? And it's normal like that. Let's check also the right channel, sorry, the left channel. So more air, you see? It's dropping, yeah? Because if you drop the temperature, also the current is dropping and it's normal. Yeah, you see both of them. So this is about the tips and tricks of this idling and DC offset. Okay, so this is about this. So you saw I adjusted again the idling current. So let's see one more time if DC offset is changed. Normally it should not be interference by this one. So you see, yeah, because I told you the idling current is not changing, is not influencing the DC offset, but DC offset is influencing the idling current, and it's normal. Yeah, so you see, both of them, they are tracking, you see, minus, plus, we can see on min-max. Yeah. If it's not proper, you can adjust. It's no any problem because you have 20 minutes to do this. Yeah, you see, now this one is sitting more on 0, this one is sitting exactly between. Yeah, also maximum and the minimum, average. So 0.6, 0.9, minus and plus. So it's correct. Minus and plus, still correct. So you see, this is how it's going. So now let's make the layout for making the performance of this amplifier. What means the performance? So the performance means like that. We'll connect this amplifier to the signal generator. Signal generator, it will come on auxiliary input number 2 or number 1. And instead of speakers, you will use these dummy loads on 8 ohms. We'll read on the dummy loads, we'll read the AC voltage, and we'll read also the output with an oscilloscope to see exactly how it looks, the frequency. So let's do together this setup, yeah? So let's start. So first of all, I will need the signal which is coming out from signal generator. So it's only one output on signal generator, and the signal is split in two, and I will connect these two jacks on the auxiliary input number 1 of amplifier. Yeah. So we'll receive the signal from the generator, and the connection, it will be exactly on auxiliary input number 1. Yeah. So let's fix this on auxiliary input number 1. So I'm trying to use, keep in mind, the red color is for the left and black color is for the right, because to be easy to understand, the channel, when you'll start to play with the amplifier to know exactly where everything is going. Now, signal is coming from the signal generator, is coming in the input, auxiliary input number 1 on the amplifier. Now, we have to connect on the speakers A, we have to connect the dummy load. Dummy load is set for 8 ohms, so we will use that two resistors which are 8 ohms. So, left channel, it will go on the left channel, right channel, it will go on the right channel. You see, meanwhile, the amplifier is running because we still have to check that measurements, yeah, in 20-30 minutes. So I will connect now the cables behind the amplifier on speaker connectors, yeah. So I will use the speaker A connector for left and right. So now the dummy load is connected on the speaker outputs, but the speakers are on off now. So now I don't have no any output to be visible by the dummy load from amplifier, and also the volume is on 0. Now I want to see exactly the power output. I will need to read the voltage which are across this dummy load. So for right channel I will use the right multimeter. So I will connect the probes here. If you want to see how I did this dummy load, I will attach a link here up and you will see exactly how I did this. Okay, and for the left channel I will use left multimeter. Yeah, so I will connect the probes here. So now I will have the reading of this voltage. This voltage here, it's AC voltage, it's not DC. Yeah? So I should change the position for the multimeters on the AC. So I will change for AC voltage. So I changed. Now we have to connect the outputs from the dummy loads. Also, it's voltage across resistor. So to be clear, we have the wires which are coming from the speakers resistor. And from resistor I create these two connections for plus and minus. And the connection for the, it's same like here for the oscilloscope out. Yeah. So, and also on the dummy load, the grounds are not common. So the minus of this resistor is coming here, the minus for the other resistor is coming here. So the grounds between the oscilloscope probes, they are not existing. So now for this connection I will connect right channel or channel 2 of oscilloscope. So I will connect like that. And for left channel I will connect channel number 1 or input number 1 of the oscilloscope. You see that there, here it's red, here it's red. Yeah, so I will connect here. You see? So now I have this connection like that. So everything now it's wired. Yeah. So let's start the signal generator. Let's start also the oscilloscope. So let's start the signal generator. So amplitude is on 0. Okay. So let's set for 1000 Hertz, 1 kilohertz. Let's start also the oscilloscope to see both lines. You see? We'll start also the voltmeters to see if it's any reading. So now the signal generator is set for 1 kilohertz or 1000 hertz. Oscilloscope have the volts per division 5. Okay. Time division it's set in that way to see both outputs from the amplifier. We'll start the multimeters to see exactly the voltage across the dummy loads. For each channel it's connected an 8 ohms dummy load. I will show you also the front of amplifier. So the dummy load is here, the front of amplifier, like I said, auxiliary 1 out input. Attenuation, it's on 0. Volume, you see it's set there. Loudness is disconnected. Tone control, it's defeat. And everything it's on 0, yeah? This is how it should be. The amplifier, it's running. We have signal, which is coming from signal generator. And we have also the multimeters where we have the reading. According to the manual specifications, they said like that. Continuous power output between 20 Hz and 20 kHz, both channels, 60 watts and 60 watts and on 8 ohms. Yeah? 1 kHz, both channels connected, driven, 65 and 65 watts on 8 ohms. Yeah? So we have to see now on 1000 kHz, on 1000 Hz, 1 kHz, we have to see 65 watts per each channel until we will see the distortion. So let's start to increase and we will see where we will have the clipping on the oscilloscope. So let's see. Let's reduce a little bit. You see both channels, they are tracking in the same time, which is really nice. Very good Pioneer. Okay, so let's start to increase until we will have clipping point. You see? So you see, it's on 23 volts. So 23.0 multiply with 23.0 divide by 8, it's 66 watts RMS. So it's according with the specification, yeah? Very good. Let's check also now the temperatures on heatsinks. So now amplifier is running to full capacity. Let's take also the temperature. 37 degrees, 34, yeah? 66 degrees on the load and 63 on the load, yeah? Because the air is fluctuating different here. You see this one is closer to the back, but you see they are similar. They are tracking the same, which is really nice. And let's see now how is dealing on 20 Hz. So let's go now on 20 Hz to see what's going on. So you see it's 20 Hz. Let's change the time base and let's increase. Here is not so easy to see the clipping, but my eyes they will see. You see, started now. You see here on the top, and we have 23 volts. So it's same, 23 multiply with 23 divided by 8, 66 watts. And they said 60 watts. So on 20 we are okay. Yeah? For 1000 we see. So let's go to 10,000 Hertz. Okay, we are on 10,000. We can see here the diagram. And now let's go until we will see the clipping. So you see, you can see the clipping here. So it's 22.6. Yeah. So 22.6 multiplied with 22.6 divided by 8, 63.8 watts RMS, both channels. So it's still on the spec because they said 60 watts, yeah? Okay, so now let's go to 20,000 or 20 kilohertz. Yeah, correct. So now let's increase. Let's see what's going on, where we'll stop. You see here, 22.8. Let's check one more time. 22.8 multiplied with 22.8 divide by 8, 64.9 watts RMS. So you see, this amplifier, he is doing a really good job. So let's check one more time the temperatures to see what is going on. Temperatures on heatsinks: 40 degrees, 38 degrees, 76 degrees, 70. Now it's dropping because I reduced the volume. So you see, they are tracking very, very nice. So this is about the performance of this amplifier. It's going really nice. So now we can declare this amplifier after all these years. It's going on a really, really nice way. This is how it looks with covers on position. You see, beautiful, shiny, glossy. And now remains only to show you all the components which they've been removed. I will put here on the top and you'll see them immediately. So here, like you see on the first row, we have the power supply board with all the parts which are out, are 27 parts on first row. On the second one we have the control amplifier. We have 27 parts which are out. After that we have the power amplifier board with 34 parts from both of channels. Equalizer amplifier, 15 parts. After that we have the protection assembly, is this one, 21 parts. We will continue with the filter amplifier, which is this one, and we have 12 parts. After that is coming switch B assembly, 6 parts, and the last one we have the switch C assembly with 4 parts. So everything what you see here, and of course here are some screws which they kept the main filter capacitor on position, and the mica pads which are already, you know, on this vintage amplifiers they use a kind of glue to stick this, so I cannot use anymore this because they are like glue. Okay, so guys, thank you for your time. I hope you enjoy this full restoration process. Here you remember, for each card I explain to you all the diagrams. I will change the camera a little bit. So like here it's power amplifier assembly board with diagram and everything, power supply circuit board assembly, protection circuit assembly, filter amp assembly, equalizer assembly, control amp assembly, switch B assembly. So everything was printed and switch C and explained to you. Power supply circuit B assembly, and of course the entire diagram where I make some sketches and I was trying to understand the signal, how it's going. So guys, this is the way how I present this journey for you. I hope you enjoy it. If you have questions, don't hesitate to let down. If you want to see these diagrams, you have to watch all the videos belongs to this journey, and you will find everything there. You can make a print screen. You have the description for all the components. You have everything. So guys, I can say this journey is finished for restoration. It will come 1 or 2 or 3 videos more with audio tests. You will see how it sounds, this amplifier on different speakers, and soon it will be ready also the tuner matched for this one is TX 9100. It will start. I will start the restoration also for this one, because like I said on the beginning, I have these 2 pieces for a long time ago, but every time I was postponed, and this mount was the time for this to fix. So guys, thank you very much. Share with others, stay safe, pay attention to the voltages, and leave comments and feedbacks down. And don't forget thumb ups and subscribe. Thank you guys, all the best. See you. Bye bye.